Okay, so we are talking about all pair shortest path problem. So we will discuss today we will discuss the Fried-Warshall algorithm. So let us just recap. So we are talking about all pair shortest path problem. So that means given a graph V comma E, directed graph, we have this V is n. So that means V is V1, V2, Vn, and for simplicity we are taking 1 to n, and we have the edge weight W, which is E to R, and which we are taking in adjacency matrix Aij. So Aij is basically, this is n cross n matrix, this is the adjacency matrix. So Aij is basically Wij if Ij is an H, otherwise it is infinity if Ij is not is an H. We cannot put it 0 because 0 could be the weight of the edges. Okay. So that is the danger with putting 0. So these are the input, and what we have to find out? We have to find out the all pair shortest path. We have to find out the delta of Ij. So this matrix. So delta is the weight of the shortest path from I to j. So for this we are talking about dynamic programming technique. So in the last class we defined some Dijs. So we have defined this Dij m. This is basically weight of the shortest path from I to j, which uses at most m edges. Okay. So that is the weight of the shortest path that uses at most m edges. So that means if we I from j, if we go and if we just count the weight, if we just count the number of edges in this path, then that number must be less than or equal to m. And we take the minimum weight, such weight. So that is our Dij m. And we in the last class we have seen this theorem. So base case Dij is 0. We know it is 0 if I is equal to j. Otherwise it is infinity if I not equal to j, and we have seen this for Ij n is basically minimum among all k such that Dik m minus 1 plus Akj. And this k is varying from 1 to n. So this is for all m 1 to up to n minus 1, and for m is equal to 0, this is the expression. So this result we know from the last class. We proved this in the last class. So now we will use this result to have the delta. So what is the relationship between deltas and Dijs? That also we have discussed in the last class. So basically, if there is no shortest path, if there is no negative cycle, then there will be shortest path. In that case, delta of Ij is basically Dij to the power n minus 1, because if there is no negative cycle, then the shortest path will be simple path. So that means we have at most m minus 1 edges in a path. So which is basically converge. This will be basically delta of n, Dij n plus 1. And so on. Okay. So if you write this in a matrix form, if you write D matrix, D to the power m is basically this Dij to the power m, this n cross n. So if you take this Dij in the ij entry of this matrix, then basically delta, which is the delta Ij matrix. So delta is basically Dij delta matrix is d n minus 1 or dn we can say. So, basically all pair shortest path problem is to find this delta matrix, capital delta. So, now the question is how we can get this matrix, how we can get d to the power n or d to the power n minus 1 or d to the power n in general, okay, because it will converge if there is no negative weight edges. Okay, so let us try to get d to the power n. So, that will be solving us to finding the all pair shortest path. So, our goal is to find d to the power n. So, where d to the power n is basically dij to the power n. Okay. So, what is d to the power m is basically what? D to the power m is dij to the power m. So, where dij is basically minimum over k of this expression dij to the power m minus 1 plus akj. Now, we'll just how to get this D matrix. So, for that we need to take help of what is called matrix multiplication. So, suppose we will relate this expression with a matrix multiplication. So, we want to claim that this is basically d m is basically d of m minus 1 into a matrix. This is sort of some sense matrix multiplication. So, what is that? How we can view that in this way? We will discuss. So, how to define this multiplication? How to define this? What is the operation? For that, let us just go back to the what do we mean by matrix multiplication of two matrix? Say real matrix. Suppose we have, so this will come back to this. So, okay. So, just concentrate on matrix multiplication. So, suppose we have two real matrix A B. So, this A is nothing to do with this A. So, just keep this separate. Now, we are talking about just matrix multiplication. Recap. Matrix multiplication. So, we are just so, for matrix multiplication what we have? We have two matrix, suppose real numbers of size n by n, it could be n by n, m by n, then n by p, but for the simplicity we have two matrix A and B, both are of same size n cross n. Okay. Now, then what is the multiplication of these two matrix? C is the A into B. This is the matrix multiplication if these are real number, or it could be over a field, we will talk about that. So, then what is the C? C is also basically Cij, which is also size n by n, and Cij is basically summation over Aik Bkj, and this k is from 1 to n. Okay, this is the formula for matrix multiplication. So, this is into, this is into. So, this into is the real number. So, if ai and bi are real number, this is the real number multiplication, two real number multiplication, and this is the real number sum. Okay. So, this we can write as this way. So, just we can write as basically if we have a function sum of k over k, then Aik into Bkj. That way we can write. So, can we relate this expression with this expression? So, we can just instead of sum operation, if you think this is a minimum operation. So, minimum among this all k's, this k is varying from 1 to n. And then addition if we replace by this multiplication, this real number multiplication, okay, then this is nothing but a matrix multiplication. just think about it. If we just relate this expression with this expression, this minimum is basically this sum, okay, and this multiplication is basically this addition. Then this is basically a matrix multiplication. So, if we just relate this, if we just this minimum as a sum and then this plus as a that into, then this is nothing but the same expression as this. So, in general, if these numbers are coming from a field, this we are talking about real field, if in general it is coming from a general field and we have a operation on the general field, one operation is multiplication operation, another operation is summation operation, this summation. So, similarly, if we have another if we have a operation say star and say this symbol, then also we can define this matrix multiplication over this field. Suppose we have a field with these two symbols, provided this satisfies some of the properties, it has to be filled. So, provided this minimum and dot plus will satisfy the those field properties. So, let us assume these are satisfying those properties, one can prove this. So, this is nothing but a matrix multiplication if you compare this expression with this. So, that means this is our A matrix basically. So, A is basically this is coming from D m minus 1 and this is our matrix which is basically compared to B matrix. So, this is basically the adjacency matrix. So, that is it. So, this is the basically the matrix multiplication. So, we prove this. So, this is basically Dij m is basically, so this result is dm is basically dm minus 1 into A, and this m is varying from 1 to up to n minus n. And what is, if we put m is equal to 1, what is d0? d0 we know, d0 is basically this matrix. So, this diagonal element are all 0 and off diagonal all are infinity. So, this is serve as an identity matrix, this serve as an identity matrix, we can check that under these two operations. Our operation is minimum and this plus. So, we have to be little careful while we are finding this Dij's D matrix. Okay. So, our operation is minimum and this plus. So, this is a good news. So, we have this Dij's with this we have the expression for dm with this identity matrix. So, we put this over here. So, we will use this. So, what is then d2? So, d1 is basically d0 into A. Now, this will serve as identity matrix, this is basically A. Okay. This is basically A. And what is d1? d1 sorry d2, d2 is basically d1 into A. Now, d1 is A, so this is basically A square. So, this way we can just proceed, dn minus 1 is basically d to the power n minus 2 into A, and which is basically A to the power n minus 1. Okay. Now, so this will give us, so A is the adjacency matrix. So, basically now if we can find d to the power n minus 1, that will give us basically delta of Ij, delta matrix. So, to find d to the power this, we have to find which is same as this is converging. So, which is same as if there is no negative cycle. So, basically our problem is to find a to the power n. So, if we can find a to the power n, then we are done. So, now the question is how to find a to the power n. So, this is basically matrix multiplication. So, this is a how many times matrix? N times. So, each time matrix multiplication will take this is matrix of size n cross n. So, order of n cube. So, time will be n into n cube. So, n to the power 4, which is not as good as if we run the Bellman code for all pair shortest path. So, how to simplify this? We can use this, we can simplify this matrix multiplication little bit. This is the naive approach. So, this is what? This is A into A. So, n times. So, each time we are doing a matrix multiplication with a cost order of n cube, provided we can handle that two operation minimum or plus, because we are not in real matrix. Okay. So, you have to be little careful about the field. So, our field is just this operations are minimum operation and the plus operations. Okay. So, now how to improve this matrix multiplication? So, we can improve by just one can improve by this repeated squaring. This is the improvement of improved matrix multiplication. Okay. So, we can improve by repeated squaring. So, how a to the power 2k is basically a to the power k into a to the power k. So, that means, so we have to find a to the power n. So, to find a to the power n, what we can do? We can find a square, a 4, then a to the power 8, like a to the power 2 into log of n, sort of a lower ceiling or upper ceiling. Anyway, so this is the way. So, this will give us how many time? This is log n such squaring. So, that means it will take order of n cube log n, which is not much benefit from that, because yeah, earlier it was order of n to the power 4, now it is order of n cube if we do this multiplication little carefully. And to detect the negative cycle, so if we have to detect the negative cycle, then it will not converge, and we have to check the diagonal element. And so, we find e to the power n say, and we check the diagonal element, and if the diagonal element has negative value, then there is a negative cycle. So, this is how we detect the negative cycle. Okay. So, now we will discuss a better algorithm, which is called Foyt-Warshall algorithm, which will give us the order of n cube time for finding these deltas. So, for that we define new variable Cij to the power k. So, let us just have this Foyt-Warshall algorithm. This is also a dynamic programming algorithm, but which is faster than the one we have seen. So, Foyt-Warshall algorithm. So, this is also a dynamic programming technique. Okay. So, what we are doing here? We are defining. So, instead of Dij, here we are defining Cij to the power k. So, this is basically weight of the shortest path. So, here we are numbering the vertices. We already have numbered the vertices V1, V2, Vn. So, this is basically 1, 2 up to n for the simplicity. Okay. So, weight of the shortest path from I to j, node I to node j, with intermediate vertices values are less than equal to k, with intermediate vertices belonging to belonging to the set 1 to k. So, what is the meaning of this? Suppose we are at I, we want to go to j, and in the middle we visit some vertices dot dot dot. So, this vertex numbering must be less than equal to k, that is the meaning. And we have no restriction on I and j could be more than k, but we have a restriction of the intermediate vertices. So, the intermediate vertices we see their number must be less than equal to k. So, that is how we define Cij k. Okay. So, for example, if we just find out C 4 5 3. So, this is basically we are at vertex 4, vertex 5. Now, we consider all the path from 4 to 5 such that if we see a vertex over here, intermediate, all the intermediate vertices dot dot dot, they are either 1, there must be less than equal to 3. So, they are either V1 or V2, any of these, either V1 or V2 or V3. So, this is the restriction, all the vertices must be less than equal to 3, and we take all such path and we take minimum among that. Okay. So, this is how we define this Cij's. Now, let us have the recurrence from this Cij, so that we can have the dynamic programming technique for that. So, okay. So, what is Cij 0? What is the meaning of Cij 0? Cij 0 means we are at ith vertex, we want to go to jth vertex. So, because there is no vertex number h, so if we have vertex in the middle, there has to be some number. So, we are not allowing that. So, that means there is direct edge. So, this is basically Aij. Aij is the adjacency matrix, Aij is the n cross n, where Aij is Wij if Ij is an h, otherwise it is infinity if Ij is not is an h. Okay. So, Cij 0 is Aij, and what is the other expression for Cij? So, Cij k we have to write in terms of k minus 1. So, we claim that Cij k is basically minimum among Cij k minus 1, that means we are not seeing the vertex kth vertex, I mean vertex which is number k, or Cik k minus 1 plus Ckj k minus 1. Okay. So, how to prove this? So, this k is from how to prove this? So, we are at ith vertex, we want to go to jth vertex. Okay. Now, it may happen and we do not want to see a vertex whose number is more than k. So, it may happen that we are not seeing at all the kth vertex. So, that is one possibility, that is Cij k minus 1, and another possibility is we may see the kth vertex in the middle. So, if we see the kth vertex, then we go to the kth vertex, then this. So, this is basically Cik k minus 1, because in the middle we do not want to see kth vertex, because if we see kth vertex, that is a self loop, that is a cycle, and since shortest path will exist if there is no negative cycle. So, that we can ignore that cycle. So, similarly, this one is also Ckj k minus 1. So, these are two possibilities. So, minimum among these two. So, this is a path, we take this plus this and this. So, these two are possibilities, we take minimum among these two. So, this will give us, this is the proof. Now, so now how this Cij k will help us to have a delta. So, basically we need to find out the delta ij. So, what is the relationship between delta and Cij? So, basically delta of ij, which is basically shortest path from I to j, is basically Cij to the power n. Why? Because if there is no negative cycle, so every path will contain simple, every path is simple path. So, we are going to I to j. So, the path we visit here is the maximum vertex are visiting is up to the vertex numbering is up to n. So, that is basically delta of I comma j. So, if we can find C I j n, we are through. So, this will be we are getting from this recursive algorithm. So, what is the algorithm? So, basically we need to find C I j with the initialized by this. So, let us have the algo, Void-Warshall algo. So, this is basically we just initialize by C matrix as A. This is the C I j 0, then for k is equal to 1 to n and do for I is equal to 1 to n and do for j is equal to 1 to n. What we do? Do if C I j is greater than C k j C I k plus C k j, then we must relax this C I j, then C I j will be relaxed, C I k plus C k j. So, this is sort of relaxation we are doing. Okay, so, this is 3, 4, 5, 6. So, that is it. So, this is basically you are calculating this C I j recursively. So, this is initialized by A matrix, this C, if we denote this C matrix, then after that this C I j is C I k is doing like this. So, this is basically C I 0, and then if we want to have this index, otherwise this is okay, because we are taking the variable, then we are updating there itself. Okay, so, this is the code. If this is greater than, we are just relaxing, otherwise this will be the earlier one. This is the earlier one, C I j m k minus 1. Okay, so, what is the time complexity for this? Basically, we have how many loops? We have 3 for loops. So, time is basically order of n cube, which is better than the earlier one. So, this is what is called Void-Warshall algorithm. So, in the next class, we will see some application of Void-Warshall algorithm. So, this is the better algorithm than. So, this is also a dynamic programming technique. Thank you.